Okay friends, so in this we will know about molecular term symbols. So this is actually not for really a priority jam, but obviously it's there for GATE and NET exam, right? Okay, so first before going to molecular term symbols, you need to know some basics. Okay, this is actually a bit of higher level, so uh, just pay a bit of attention. It won't be as easy as atomic term symbols because you need to get your basics clear. Molecular term symbols. Okay, first of all, like you guys know about gated and ungated, right? Gated is when it is symmetric. Like suppose we have an orbital uh, over here, where or something which is we can say is symmetric, right? Like a p orbital or something in the slanted form, right? And if it has the same like positive sign on both sides, we can say it's symmetric. If it does not have plus and minus at different signs, so we can say it's ungated. UG, right? Therefore, according to this only, suppose we have s orbital, p orbital, d orbital, and f orbital. Okay, in their bonding form and in their anti-bonding form, AB. So s orbital in this bonding form is gated, G in its anti-bonding form is ungated, right? P orbital in its bonding form is ungated, in its anti-bonding form it's gated. D orbital is gated in its bonding form and anti-bonding in its un antibond like ungated in its antibonding form. And f orbital is ungated in its bonding form and it is gated in its bonding form. Okay, now how do we like justify that? As I already told about you, see s orbital is like this, right? So it's obviously gated. Okay, it's like symmetric throughout in its. So whatever happens in bonding, the anti-bonding is opposite to it. In p orbital, we know in like px, py, normally it's a plus sign over a minus sign over here, so it's ungated. In d orbital, what actually happens is, suppose we have this d orbital, right? And normally what we have is like plus over here, minus minus. Okay, suppose for dxy, dxz, like that. Okay, and so plus plus, you can say it's like similar, symmetric, it's matching, it's gated, and minus minus, so it's symmetric over here, it's matching, right? It's gated, and therefore the antibonding is ungated, right? So like this only, it's very alternate, goes in alternate form, so it's, I think it's pretty easy to remember all these things, right? Okay, I'll just rub this thing out. Okay, great. So now having this cleared, we'll just look at some things of molecular orbitals. Okay, so we know that the molecular orbitals are actually have different, you can say, alignment in two cases. One, it is when it is less than equal to 14 electrons, this case, and one it is when it more than equal to 14 electrons, right? So what is like more than equal to 14 electrons? We can look at oxygen and fluorine, right? And what is less than equal to 14 electrons? Suppose the nitrogen and the lower elements like boron, carbon, and all these things. So I'll just draw the orbitals so it's easy for to remember. So first of all, we have, suppose we are drawing, I'm drawing for nitrogen over here. Okay. So first of all, I will have like we will both show the atomic orbitals as well as the molecular orbitals. Okay. So first of all, we have the 1s atomic orbital, then we'll have the 2s atomic orbital, we'll have the 2p atomic orbital, and over here as well we'll have the 2p over here, we'll have the 2s over here, and we'll have the 1s over here, right? I'll just mark this 1s, 2s, 2p, and now we'll have their forms, as in this will be like 1s. So suppose I'm not drawing the boxes anymore. Okay, suppose I'm just drawing the boxes because I've already drawn, and they'll be like I'll just draw some lines over here. Great, right? So these are actually from all these, so I'm just notifying them. So okay, 1s, this is also 1s, 2s, 2p. So these are atomic orbitals, and middle these are the molecular orbitals, right? So this will be like the 1s bonding one. So this will have like sigma g, right? Because Why? Because G is for the bonding one, we told you before, and this will be 1s star, which is the anti-bonding one, right? So 1s star is anti-bonding, so it will be sigma u, right? Because we have said for the anti-bonding of s orbital, let's u ungraded. Similarly, for the 2s over here, this will be have the sigma g form, and the 2s star over here will have the sigma u form. Now this is the part that you should note carefully. Over here we have what? We have 2px, 2py, 2pz, right? Now the 2px and the 2py, they actually form pi orbitals, and z1, this goes on to form the sigma orbital. So this is z, this is xy. Okay, so in when it is less than 14 electrons, like for nitrogen, we have this over here. These are the like pi orbitals, which is like 2px, 2py, right? Or you can say it's like pi u, pi ungraded. Why it is ungraded? Because it's the bonding form. Okay, so because it is like above, lower this middle line, right? It is in the bonding form, and above these are the anti-bonding forms. So over here we also have this thing of like 2px, 2py, but it is in the anti-bonding form. So it will come as pi g, right? Similarly, this is a 2pz1. Okay, this is 2pz, which is in the sigma g form, right? And this is the 2pz, like what do you say, the anti-bonding form, which is in the sigma u. Okay, so I hope like some things are getting cleared, and the difference between oxygen over here comes is that these things are same for the 1s and 2s, but for the 2p ones, okay, 2p ones, what happens is over here we have the sigma g, this is our pi u, this is pi g, and this is again our sigma u, right? So we see what happened in nitrogen is this was your pi u, this was sigma g, this was pi g, and this is sigma u, right? So there's a difference in configuration between this, right? What has changed? These two orbitals have interchanged, right? The sigma g and the pi u have interchanged over here. Okay, now why this happens? So there's a different reason for why actually this happens, because of the sp orbital mixing. The reason is that but I won't go into the details of this because it's a like it constantly to understand very well. So I'm going to the details of that, but note this, like electronic configurations between them and their symmetry in the form of graded and ungraded, which will be required in the next part only. So an easy trick to remember between which I use, that for nitrogen, when I have to do it quickly in MCQs and all these things, right? So what I use is that your like the when it is below 14 electrons, it is like more kind of symmetric fashion, because you see you have the pi, then the sigma, then again the pi and the sigma, like an alternate fashion. But over here it's not like symmetric really. It's like sigma, pi, pi, and then again it is like sigma, right? So when it is less, then it is like behaves well and it is symmetric, but it is when it grows up, it is like behaves badly and it is not in symmetric anymore, right? In the form of like alternate fashion and not alternate fashion. Okay, so these concepts will be helpful when we solve the next part. Now we'll actually come to the main grasp of our molecular term symbol. So I'll just delete this whole page. Just one second. Okay, so we are good to go, I believe. Okay, so the molecular term symbol, what is the form of the molecular term symbol? First we have to know that the form of this molecular term symbol is, I'll rub this part out as well. right? Great. And now the form of this molecular term symbol is actually uh, given by 2s plus 1 L. Now this will be G or U, as I have told you before, right? Okay, great. This is the form, and now we have to know some nomenclature. So when L is equal to 0, 1, 2, 3, what do we know from beforehand for like atomic? Like it was SPDF. Now it's on the same case. For over here, for S we'll have sigma, for P we'll have pi, then D will have like delta or del, you can say. It's called delta only, and F is called phi. Like this is for phi. So sigma, pi, delta, and phi. Okay, these are the term symbols we'll be using. Okay, and know this as well, like G into G, get into get it will come get it. Ungate into ungate will give you get it. Ungate into get it will give you ungate it, right? Because it's like get is like plus one, ungate is like minus one. Plus one plus plus one is like plus one, and minus one is plus one, right? So, and later on we'll also have some concepts reduced, but for the moment let us take an example and start. So suppose we are told to find the molecular term set for hydrogen. It's a molecule, right? Hydrogen and hydrogen, like two atoms, becomes a molecule. And now what we'll do is we'll have its so we'll just draw its molecular orbitals over here. So it has one s over here, one s over here. So this has one electron, this has one electron, and both mix up to become two electrons, right? So it has now two electrons, hydrogen. So one s, this is one s star, right? And this is we know as this is sigma g. Now for all sigma orbitals, okay, so what do we have to find over here? So first I'll say this and then we go to the deeper parts. We have to find that it is gated or ungated. We have to find what's value of L, we have to find the value of S. So what is the value of S? So we just look at this portion only. Okay, now this is when you look at the molecular orbitals. What is the value of S? S is equals to half minus half equals to 0. That means 2s plus 1 is equals to 1. So we have found 2s plus 1 already. Now let us find for L, right? So what is L? So now we know that for L orbital it is actually equal to over here. What is L? This is like this is no value, right? This is like 0, the ml value, right? So it's like 0. So what does correspond to 0? It's like sigma, right? And normally what happens is for all sigma orbitals, right, when it is just one orbital, the L value is actually equal to 0. Why? Because there's only one orbital, right? The ml value has to be 0. Okay, you'll get this concept more clear as we do some more examples. Okay, now we have two electrons over here. Now we have found out the L value as well. Now we have two electrons over here. Okay, both are in gated, so it will be G into G equal to G, right? So we have found out the molecular term symbol. What is the molecular term symbol then? It is 1 sigma G. Now here comes another portion. Sometimes there is a concept of over here plus or minus mentioned. Now how do you know whether it's plus or minus? Okay, only when L has this value of sigma, only then it will be plus or minus. For pi, delta, phi, there wouldn't be any concept of plus and minus. So when will it be plus? Okay, when the 2s plus 1 value is equals to 1, it will be plus. When the 2s plus 1 value is equals to 3, it will be minus. So these things you have to remember, right? Because there's a very big derivation for this, how this comes and stuff. Okay, so just remember that when the 2s plus 1 is actually equal to 1, it is 1. When the 2s plus 1 is actually equal to 3, it is your gives minus sign, right? Now we'll look into some other examples. Okay, so I'm rubbing this part out. Okay, great. So now let us look into this famous example of oxygen that we were talking about. Let me write over here. Oxygen, right? So oxygen has 16 electrons, and what can we say? First, again, we have to find the molecular term symbol of oxygen. So first, what we'll do is we'll again draw the molecular orbitals. As I said before also that the 1s2 and the 2s2 actually won't contribute over here. We'll only look for the outermost ones, which is 2p. Why? Because we'll just look at the vacant or the last electrons, right? The outermost electrons. That's why. And over here, so 2p, like 2px, 2py, 2pz, right? And for oxygen, as I've just told you before, it follows this fashion, where this is sigma g, this is pi u, this is your pi g, and this will be your sigma u. And similarly, you will have 3 over here as well. This is the molecular, this part is the molecular, and these part are the atomic ones. Right? Done. And over here, uh, so let us fill the electrons. So in p orbital, so oxygen has 16 electrons. So one oxygen has, you can say, 8 electrons. And out of the 8, we know that in the outermost, it has like one, in 1s it has 2, 2s it has 2, and then the 2p it will have 4. Right? So we just fill up 4 electrons, like 1, 2, and then 3, and then 4. Right? Know this pattern of filling up. It's not like 1, 2, or like 1, 2, 1, 2, 3, 4. Going in relation, or so we have to fill like 1 2 in one orbital first, and in the second orbital, you know that in by Pauli's exclusion principle, the electrons want to stay unpaired as far as possible, so that's why they don't get paired up and they stay like this. So this is our final so sorry for that, actually over here also we'll have 4 electrons, 1 2 3 4. So in the actually we'll have 8 electrons, so we'll have fill up more, 1 2 3 4 5 6, again 7, and again 8. So this is our final configuration. Now we'll look for the term symbols. So first what we can do is find out S. So I'll just take this portion only, right? So S is what over here? It is half plus half, which is equals to 1. That means 2s plus 1 is equals to 3, right? And so both electrons are in G, right? So we have found out S and 2s, so we find out G and U. So electrons are in G, so it's G into G, which is equals to G. So it's the gate. Now we find out for L. So this is a tricky portion, or a portion that the concept you need to know. That for Pz, value of L is 0. For Px and Py, the value of L is plus 1 and minus 1 respectively. Okay. So what is this? I have told you before that this sigma is from the sigma is from Pz, and this pi is from Px and Py, right? So Px over here we can say it's plus 1, again Py is minus 1. So plus 1, so what we'll have over here, we'll have plus 1 and minus 1, which is equal to 0, which is, so it is sigma. And so we can say it is 3 sigma g. And what I told you before, there's a concept of plus and minus, and when the 2s plus 1 is 3, it will have minus sign. When the 2s plus 1 will have plus, it will have positive sign, right? And so this is for oxygen. Now very quickly I'll tell you some variations of oxygen and what their term symbols are. For example, suppose I take O2 plus. What is O2 plus? It has 15 electrons. Just cancel this one electron out. Cancel this one electron out from this molecule, and you will have what the difference over here? When we cancel like one electron, the S value will have half. That means 2s plus 1 value will be 1 plus 1 2, right? And the G value will be like G only because it's only, sorry, it's in G only, so it will be G only. And the L value will have a change. What I said, Px is plus 1. Plus 1, that means it will have pi now. So what is the term symbol? It will be 2 pi G. And I told you like pi, only sigma will have this concept of plus and minus. The pi delta and phi will not have plus and minus. And now over here we'll have another variation which is O2 minus, right? And in O2 minus, what we know is just add one more electron over here, right? So what is the S value? Now we have half minus half, which is because it's paired up, and again half, which is in the py orbital. So we'll have half, and the 2s plus 1 will be 2, right? And now the electrons are in what? It is G into G into G, so it's G. No issues with that. And now, what is the L value? The L value is plus 1 because 2 are in px and 1 in py minus 1. So it's plus 1, again it's pi. So the term symbol is 2 pi g, right? So these are the variations of oxygen. And now I'll quickly tell you how to find the maximum or the most stable like configuration of these three. So what are the three configurations we have? We have 2 pi g, like this is also 2 pi g, and one we have is 3 sigma g minus, right? Out of this, which one will be, you can say, like more stable or something like that? Okay, I have already told you the previous example that the maximum value of S will be the most stable. So 3 sigma g minus will be the most stable, or it will have the least energy. And if you're told to like assign ground state between these two, this will be the ground state, right? And after S, what we will look at? We will look at sigma, the maximum value of L, right? So but first we look at S. So if we would have looked at first value of L, then this has actually more value of L because it's L equals to 1 over here, but the value of S is less, right? So these were the rules, right? And now I'll show you some more examples which can come in the exam. So again, I'll just rub this portion out. Okay, I don't want to use this page actually. Great, great. So let us now take this example of NO, right? NO. So NO is a different kind of example, but what we know, N has 7 electrons, O has 8 electrons. Total it has 15 electrons. So the molecular, so now this is a tricky question. The how we should align the molecular orbitals. Now, we said it before that when it is less than 14 electrons is one rule, when it's more than 14 electrons is one rule. Well, how many electrons over here it has? It has 15 electrons. So it will be filled up just as the way oxygen was filled up, right? So this is sigma, this is pi u, this is pi g, and this is again sigma u. Okay, so these are the, like you can say, nitrogen orbitals, these are the oxygen orbitals. Nitrogen last orbital will have 3 electrons, right? The p orbital will have 3 electrons, the oxygen p orbital will have 4 electrons. This is simple, you can say 9-10 level chemistry we are doing right now. So and now we just fill it up. We have 3 over here, we have 4 over here, and I told you this will be sigma g. The pattern of filling up 1, 2 over here, 3 over here, 4 over here, 5 over here, 6 over here, and 7 over here. Right, done. Now we have to find out S. S is what? Half. 2s plus 1 will be equals to 2. It is in the G form. L value will be 1. It is in px, right? And so L value will equals 1 and it will be equal to pi. A very tricky part over here is this G. Why? Because in NO there is actually no center of symmetry. These are like two different atoms. So it will have no concept of G or ungated because there is no center of symmetry, as there is no center of symmetry. So the term symbol will be 2 pi. That's it. Now we come to some forms of carbon, which is also very interesting to note. So suppose now we have over here carbon C2, which actually has 6 and 6, 12 electrons, right? And so let us actually try to do it for C2 2 minus. Let us actually like make it a bit tougher and let us do it for C2 2 minus, right? So let us first fill for carbon only and then we will look at this. So C2 2 minus will have 14 electrons, right? So for carbon it will follow the pattern that it has followed for less than 15 electrons. So this will be like this. It will be like pi g sigma u. Okay, I messed it up. This is sigma g and this is pi u. And this will be pi g. This will be sigma u. This is g. This is u. Yeah, cool. So there are 14 electrons and again the p orbitals of carbon over here and here. And so what we'll do over here is simply fill it up, and we know that the p orbitals of carbon has, so carbon has like 4 electrons, right? So the p orbitals of carbon will have over here 1 2 3 4, because there's 6 electrons and 4 electrons are already used up in the 1s and 2s, so it will have 4 electrons and 1 2 and 3 and 4, right? Okay, I'm sorry for this. I made a mistake over here, a lack of concentration. Okay, great. So it will be 1 2 3 and 4. This will get first filled up, right? Then it will go to the next orbital. Okay, so this is for carbon. For C to 2 minus, what will happen? We'll have 2 electrons in this orbital, right? Okay, this is sigma g. Now let us find s. S is half minus half, which is equals to 0. 2s plus 1 will be equals to 1. And it will be g into g, which will equal to be g. And then, right, what is the value of L? It is equal to 0. I told you from sigma, whatever value of L, it is 0. It is sigma, uh, 2s plus 1 is 1, this is g. And I told you this concept plus and minus will come, and when 2s plus 1 is equal to 1, there will be a plus sign, and when it is equal to 3, it will be a minus sign. Okay, so suppose we do it for C2 plus now. C2 plus, which actually has like 11 electrons, right? So I'll just change this bit only, right? For 11 it will just have this portion like pi u. So the C2 plus in over here, just rub the sigma out, which was there from before, right? Great. So for 11 electrons, what we can do is right now, so we have this. Okay, just focus and you will understand. So this is a just change portion, right? Just change portion over here only. This pi u, it is 1 electron, and so what we can say is right now that 11 electrons and 2s plus 1. So s is what? S is half, and 2s plus 1 will be equal to 2, right? And now we come to g and u. So it is u, right? Because it's pi u. And now value of L, which is equals to 1 because it's in px, so it will have the value of pi. So the term symbol is 2 pi u, right? So these were like some examples of finding molecular term symbols. It was a big video, but if you have watched it carefully, I believe you have understood everything. So with this, we will end this, and in the next video, we will see about transitions in diatomic molecules, like which transitions are allowed and which transitions are forbidden. So I hope you liked it, and do support this small channel by subscribing to it. Okay, great. God bless you, and practice also, because as much as you practice, the better it will be.